Hi everyone, I'm Sang Kim. In this video, I would like to share how to get multiple regression outputs manually. In the previous video, I showed you how to get multiple regression outputs. So there are three main tables, so regression statistics, ANOVA, and regression coefficients related table. If you are familiar with multiple regression analysis, then we need to understand analysis of variance. So this is the formula. So regression sum of square, sum of square error, and total sum of square. There are two special metrics, H and J. H is head matrix, and we can get H matrix by using this formula. And J is n by n matrix with element as 1. So let's give a name, this one as J. Again, J. Okay. Right. Then by using this matrix computation, we can get multiple regression coefficients. So select some cells here, and M inverse, and merge, transpose, x, comma x. And then merge, comma, transpose x, and finally let's multiply by y and merge, comma y. Okay, and press Ctrl Shift Enter. Right. Then we can get y hat by using these regression coefficients. So intercepts plus x1 regression coefficients, press F4 times C2 plus x2 coefficients times D2 plus x3 coefficients times E2 times E2 plus x4 coefficients times F2 plus x5 coefficients times G2 plus x6 coefficients, comma, H2 times H2. Okay. Right. Then y minus y hat square. Okay. So as you know, y minus y hat square is equal to sum of square of error. So sum. Okay. Then degrees of freedom, residual degrees of freedom. Here n minus p. So sorry, there are 30 observations minus 7 regression coefficients. Okay. Total sum of square degrees of freedom is 29, and regression degrees of freedom is 7 minus 1, right? So 6 plus 23 must be equal to 29. Okay, and then sum of square of regression. So yeah, we can okay. So instead of calculating sum of square, regression sum of square, so let's get total sum of square first. Then we can use this one to get SSR. So merge, transpose y, comma y minus 1 over 30 times merge, transpose y, comma j here. Okay, and then merge, comma and y. then regression sum of square can be calculated by total sum of square minus error sum of square. Okay, and then MSE here, SS over degrees of freedom. So this is MSE, right? So let's give a special color here. Then MS R, SS R over degrees of freedom. Okay, and F value. All right. So significance of this regression model can be calculated by 1 minus f dot dist f value here, comma degrees of freedom, comma second degrees of freedom, comma true. Right. So this is very small, smaller than 5% significance level. So we can say that this regression model is statistically significant. Okay, let's move on to get regression coefficients part here. So in order to get standard error, we can think of this formula. So select this cell here, 7 by 7. So MSE here times M inverse. Okay, emerged x comma x. Okay, so MSE times x prime x inverse. Then press Ctrl Shift Enter. What's wrong? Emerged. Sorry, it should be transpose. Emerged transpose x. Okay. All right. We were able to get sigma square of b matrix. Then this diagonal elements we need to extract these diagonal elements for standard error. So we can think of VLOOKUP function. VLOOKUP value here, comma lookup table here. Selects table array. Press F4, comma. Yeah, we need to this one is from this column 134 is located second column. That's why I added 1 and first. Right. Yeah, so I extracted diagonal elements by using VLOOKUP function. Then standard error is square root. Okay, square root of this data. Okay, right. Then T statistic coefficients over standard error. Okay, there are minus T statistic. So in order to get p-value, this is two-sided p-value. So we can think of this formula: 2 times 1 minus T dot dist and ABS, absolute value of T statistic, and degrees of freedom as 23. True. Right. So as you can see, there are significant variable here, also very large p-value x variable, it means that it's not significant in this model. So in the next video, I will explain how to deal with this significant variable and not significant variable. Anyway, let's get lower bound and upper bound. So coefficients minus theta IMV, probability as 0.975, degrees of freedom as 23, and times standard error here. Okay, then we can use this formula for upper bound, but we need to change minus sign to plus sign. Right. Excel actually provides 2 additional columns, but it's same as this one. Anyway, this is regression coefficients related statistic. Yeah. So a standard error, t statistic, and p-value, and lower bound and upper bound for coefficients. Okay, the final one is to get regression statistics. So R square, as you can see, can be calculated by regression sum of square, this one, and over total sum of square. Right, 0.73, multiple R can be calculated by square root of R square. Okay, and adjusted R square, we can use this formula. So adjusted R square is more useful than R square, because adjusted R square can control number of variables. So when there are more and more x variables, R square tends to increase. So that's why we need to we prefer to use adjusted R square. Okay, so 1 minus SSE here over degrees of freedom, and over SST over degrees of freedom. Right. So standard error can be calculated by square roots of MSE here. Right, that's it. So we were able to get all tables data, right? So regression coefficients by using this formula, and standard error is from MSE times x prime x inverse, right? Then by using t statistic, we can test whether this variable is significant or not. And this ANOVA table, again, we calculated sum of square of regression, residual, and total. Then we were able to test whether this model is significant or not. So according to this small p-value, we can say that our current model is statistically significant to explain y variable from 6 independent x variables. And adjusted R square is 0.66. That's it for today. I hope it was useful for you to understand how we can get multiple regression outputs manually in Excel. Please click like and subscribe if it was useful for you. Thank you.